workshop today. We are so excited to be at Skidmore College and really grateful to the Tang Museum for hosting. Skidmore has a big commitment to environmental sustainability, focused mainly on climate action and environmental literacy. This talk combines the two of them, so we're really excited, trying to focus on including our staff and faculty more, which we see many of them in our audience in person. My name is Celia Darling. I am the sustainability coordinator here. I am delighted to introduce Paul Stathis, who works with TRC Companies, supporting Experience Clean Heat as a NYSERDA heat pump promotion program. So I'm going to let Paul take it away. Thank you so much for being here.
Awesome. Yeah, thank you. All righty. Okay, and I'm just going to get my microphone turned on. So thank you for the introduction. My name is Paul Stathis, and I'm here for the Experience Clean Heat program tonight. And I am here to talk to you about heat pumps, and specifically the systems that Skidmore uses. So first off, a little background about the program. So Experience Clean Heat is a partnership between NYSERDA, local businesses, colleges, libraries, and other public spaces to help get the word out about heat pumps and let people experience them firsthand and really get a sense of why they are the best and cleanest heating and cooling solution. There is also a social media component to the program where NYSERDA does paid posts to drive general awareness about heat pumps and also drive visitors to the partner sites. So across the state, we have 46 sites, over 65 million impressions on social media, plus 36 events like this one and counting. Across the state. And I am here tonight because Skidmore uses a bunch of ground source heat pumps across campus to heat and cool their buildings. So you are experiencing a heat pump right now. And if you do want to check out a few of our other sites, Fort Ticonderoga, the historic site and museum, uses a combination of air source and ground source heat pumps. And the Swedish Chef in Ballston Spa, it's a specialty bakery, they use air source heat pumps to heat their space. So yeah, go check them out if you're in the area. Alrighty, so what is a ground source heat pump and how do they work? So generally speaking, a heat pump is a machine that moves heat from one place to another using a fluid called a refrigerant. So an air conditioner is a heat pump, a refrigerator is a heat pump, both versions that we're probably all familiar with. So for the air conditioner, it's moving heat from inside the building to the outdoor air. And for the fridge, it's moving heat from inside of the appliance out to your kitchen. And that is why inside of the fridge is cold. And if you ever feel around the back of a refrigerator, it is much warmer than the rest of the room. So that is where that heat is ending up. So a ground source heat pump does essentially the exact same thing. During the summer, it will remove heat from a building to cool it off. And ground source systems in particular will then take that heat. They'll be able to pump it underground and reject it down there instead of to the air. And all of the heat pumps that we're talking about today are also reversible. So in the winter, you can get that refrigerant to run the other direction, and you can pull heat out from underground and bring it inside of the building. So you might be wondering why bother to go underground to get this heat and where is it coming from? Over the course of the year, the ground absorbs heat from the sun. And once you get away from the seasonal swings in air temperature, usually about 6 feet down or so, the ground is a very stable temperature year-round. So ground source heat pumps can take advantage of that, and they can access that heat source that is much warmer than the air, even during the coldest winter weather. And all heat pumps, regardless of whether they're ground source or air source, are also taking advantage of the fact that it just takes less energy to move heat around than to create it. So to put some numbers to that, if you have an old, inefficient furnace or boiler, it might be somewhere in the 60 to 70% efficiency range. Newer, kind of mid-tier fossil fuel equipment, about 80%, and a high-efficiency condensing boiler or furnace can get up above 95% efficient, which is very good, but there is just no way to crack that 100% threshold. It's just not physically possible to get more energy out of the fuel into the building than there is in the fuel to begin with. So to do better than that, you have to go for electric heat sources. Electric baseboards and other resistance heat is considered 100% efficient. So if you convert electricity to heat, any heat that you have created, you by definition used up that electricity. Any electricity that passes through, you haven't used, so it's considered 100% efficient. Then here's where the heat pumps really let that efficiency take off. So an air source heat pump around here, even with the very cold winter weather, will average 200 to 300% efficiency over the course of a heating season. And then way up at the top of the efficiency ladder is ground source heat pumps, which can get 300 to 600% efficient, meaning that for every unit of electricity that you put into a ground source heat pump, you're getting 3 to 6 units of heat out. And then this photo is of a residential setup for a ground source heat pump. So you can see it looks pretty similar to an air conditioning air handler. It ties into some ductwork. And then in the lower right of the heat pump box there, you can see where the piping runs out to the ground loops. This system does also have some hot water tanks, so it can provide both the space heating and hot water needs for the building. All right, and then generally speaking, ground source heat pumps are broken down by the type of heat exchanger they have underground. So I'll start off with what Skidmore has, which is called a closed vertical ground loop. So that is a sealed system of pipes that has a mix of water and a non-toxic antifreeze in it that runs to and from the building and then out to a field of vertical wells that run several hundred feet underground. And those give the system a lot of extra surface area underground to exchange with that steady temperature. Next up, on the top right, we have the closed horizontal ground loop. That's a very similar setup to vertical, a sealed system of water and antifreeze, but the ground heat exchanger is laid out horizontally in a wide trench, usually about 6 feet or so underground. Then on the bottom row, bottom right, we have this cone-shaped system. That is called direct exchange. So instead of having those water and antifreeze pipes, this just buries the refrigerant lines directly. So if you imagine a central air conditioning unit, if you just unraveled that, you got all that copper pipe out of there and buried that directly underground, that's essentially what these direct exchange or DX systems are. Then moving along, these ones are a little bit more situational, but bottom middle we have an open water loop system. So if you have access to a pond, lake, a river, or even just a water well that can produce a large volume of clean water, a ground source heat pump can actually extract heat from that water, and then you can dump the water either back to the ground or back to the water source. And then the last one with that slinky-shaped heat exchanger under the water is a closed water loop. So this one is really similar to the horizontal ground loop. But again, if you do have access to a body of water, something that will be large enough that it won't freeze over the winter, you can save yourself some digging by just sinking the ground heat exchanger under the water rather than digging the horizontal trench. And there is one more option for ground source heat pumps, which is called district heating. And that's where multiple buildings share a single set of ground loops. And the reason why you do this is because different buildings call for heat and cooling at slightly different times. And you're always designing for the peak demand. So by spreading that across multiple buildings, it lets you spread out that peak demand and build fewer ground loops overall and install usually lower capacity equipment. There are also some systems that can transfer heat between the buildings, not just out of the ground. And Skidmore does have some of these systems. And so one of the use cases for transferring heat between the buildings is, let's say that you have a room like a computer lab that's full of equipment that is putting off heat year-round. You would want cooling in there year-round. So rather than running a traditional air conditioning system where you would just be rejecting that heat outside, during the winter, you can take that heat and put it to use somewhere where you would want it, like a classroom or a dorm. All right, and Skidmore's systems by the numbers. Skidmore has been installing geothermal systems for 20 years now, and now is at the point where about half of the campus is heated and cooled by geothermal systems. And just one note about terminology. Some people will use ground source heat pump and geothermal interchangeably. I do that, so if I go back and forth, don't mind me. Geothermal can also refer to going much deeper for much higher temperatures to generate electricity. That's not what we're talking about today. We are strictly going a couple hundred feet down, getting steady, moderate temperatures for space heating. So Skidmore has 3 of those district systems, plus 23 standalone ground source heat pumps, serving a grand total of 33 buildings and almost 1 million conditioned square feet. And for some context, this is the map of campus to show you where the ground source heat pumps are. And I am going to highlight some of these buildings in more detail now. All right, so first up is the dining hall. So this is one of the standalone systems. It has 48 of those vertical wells. And one of the interesting things about the dining hall is because of the commercial kitchen, because of all those stoves and grills, it has very high ventilation needs. Basically, you need to remove a huge volume of air out of the building. And without doing that in a controlled manner, for every unit of air that you remove from the building, a unit of air is going to leak in from the outside. So if you're trying to heat a building, that can cause problems if you're pulling in unconditioned cold air from outdoors. So the solution to that is, without mixing the 2 air streams, putting the exhaust air and the incoming air in contact with each other in separate channels, so that as they pass by, you cool off the exhaust air and you preheat the incoming air. So then that recycles a bunch of that heat that would otherwise be wasted, and it takes a lot of load off the heat pumps too. And then the first of the district systems is the Arts Quad geothermal field. So this is a larger bore field at 119 wells because it's shared between multiple buildings. So this one serves the Sasslin Art Building, Filene Hall, Zankel Music Center, and is prepared to serve the Bernhard Theater as well. And that's another important point about the district systems is they are very flexible. So as the needs of campus change, as buildings get built or renovated, it's possible to either add them to the field or increase the number of wells in the field to meet whatever your needs are. Okay, so district system number 2, and the one that you're experiencing right now is the South Campus geothermal field. So this one has 104 wells. It's serving Wicking Hall, this museum, and the Dance Center. And again, just to highlight the flexibility of these systems, this was built originally in 2014 and then had 40 more wells added onto it in 2024. Okay, and then the newest and largest of the district systems is the North Campus geothermal field. So that's 240 wells, and this was the system that got Skidmore up to that 50% geothermal number. So right now, this field heats and cools the Center for Integrated Sciences, and it has the possibility in the future of supporting the Tisch Learning Center, Bolton Hall, Palo Mountain Hall, and the Dana Science Center. And one last system to highlight is the Zankel Music Center. So this is part of the Arts Quad district system, and it is one of the systems that can transfer heat to other buildings that it's connected to. So if you imagine this theater being full of people, people give off heat, they breathe out carbon dioxide and excess moisture. So the Zankel Center also uses a heat recovery wheel, very similar to the dining hall, where you can remove that carbon dioxide, that excess moisture, all of the stuff that you don't want, and recycle that heat. And if the heat from the people in the audience ends up being more than the building needs, then you can just send it to another building in that district. So then to put this into some broader context, the 3 district systems that Skidmore has, they reduce the size of the ground source heat pumps that you need for those buildings by 25 to 35%. So even on top of the incredible efficiency of ground source heat pumps, this gives them an extra bump. Skidmore does also have solar thermal systems that provide about 30% of the residential hot water needs, and has done a lighting retrofit project that reduces the electricity usage by 18%. On the electricity generation side, Skidmore has a 2.1 megawatt solar array that produces about 12% of the campus's electricity, and a hydroelectric dam that produces 18%. So taken all together, all of these measures mean a 52.6% reduction in campus greenhouse gas emissions since the year 2000. Yeah, so that is a huge drop. And then where ground source heat pumps fit into this specifically is because they run on electricity and they are incredibly efficient. Right now they have the lowest emissions of any heating source. And as the electricity that supplies the heat pumps gets greener, so do they. So as of 2021, about half of the electricity in New York State came from zero emission sources. And with Skidmore having solar and hydroelectric resources, that just makes their electricity supply even greener than that. In addition to the climate benefits of ground source heat pumps, because they are not combustion appliances, they also help with indoor air quality and outdoor air quality. So they don't produce any particulate pollution, and there's no risk of carbon monoxide poisoning inside of the buildings. All right, and then I did want to just talk over a few myths about ground source heat pumps, just things that are floating out about them in the world that are not entirely true. So the first one is that ground source heat pumps can only be used for heat in mild weather. And I think considering the winter that we've been having lately, I can be pretty brief about that one, but we'll touch on it anyway. The second myth is that ground source heat pumps only work for new construction. Third, that ground source heat pumps only work for large commercial buildings. And the last myth is that ground source heat pumps are only feasible if you have large plots of land to work with. So first up, that ground source heat pumps only work in mild weather. So going back to the beginning, since ground source heat pumps use that nice, steady, temperate ground temperature, they can heat and cool year-round and maintain their efficiency while they're doing it. So you can run them during any outdoor conditions. All right, next myth, that ground source heat pumps are only for new construction. And because of the excavation that's involved with ground source heat pumps, some people think that they are not appropriate for retrofits, but that is not the case. Actually, the dining hall project here at Skidmore was a retrofit. So back in 2007, they briefly shut down the dining hall, dug the wells, installed the indoor units for the system, and got it all back up and running. So yeah, ground source heat pumps can tie into existing ductwork and hydronic heating. And that indoor unit really doesn't take up any more space than a boiler or a furnace, the kind of usual fossil fuel equipment that it would be replacing. All right, and next myth, that ground source heat pumps are only for large commercial buildings. Since we've been talking about a college campus, we have been talking about larger buildings, but the fact is that 40% of ground source heat pumps are installed in residences. So you can put those ground heat exchangers under lawns, gardens, driveways, even under the house itself, if it's still under construction. And actually the most common ground source heat pump that's sold is a 3-ton unit, which would be suitable for a single family house. Alrighty, and then the next myth is that ground source heat pumps are only viable if you have large plots of land. And there is some nuance to this one. So this depends a lot on what type of system you're installing. So if you look in the horizontal ground source heat pump column, to heat a 1,500 square foot house, you would need about 3,000 square feet of outdoor space to install the ground loop. Because if you'll remember, those horizontal systems, they need a wide trench. So 3,000 square feet, is quite a bit of space. If you have it, great, but if not, there are plenty of other options. So the vertical systems that Skidmore uses for the same heating needs, for the same size building, you would only need somewhere between 150 and 700 square feet of outdoor space. And then if you are much more if you are much more space constrained, you can use a direct exchange system, which not only has a tiny outdoor footprint of 100 to 150 square feet for that same 1,500 square foot house, but the drilling equipment is also much smaller. So typically for a vertical well system, there's a truck with a drill rig on the back of it. If you've ever had or seen a well installed at a house, just a plain old water well, it's the same technology. And then direct exchange systems use a much more compact purpose-built drill. All right, and then I am going to leave this up for just a minute if you want to grab a photo of these links. So these are just some more resources for you all. So number one is a little bit of general information about energy efficiency. Number two is the heat pump planner. So if you're interested in heat pumps for your own home, that can help give you a sense of what options are out there. Number three at the QR code is a heat pump quiz that we put together for Experience Clean Heat. So now that you've seen the talk, you can scan the code and give it a shot. And the last one, number four, is the link to the Experience Clean Heat website. So you can find out some more about the program, or if you want to visit some of our other participating sites, you can see the full list there. And I'm just going to wait 1 sec, make sure everybody's got the photos if they want them. All right. Okay, great. And then I do have some heat pump trivia questions for the group. So it's Price is Right rules. So the person who gets the closest without going over wins a Experience Clean Heat tumbler and a gift card. So for the gift cards, I have $25 gift cards to the Skidmore shop and $10 Amazon gift cards. So that'll be first come, first serve as we go through these. All right, so first question. Since the year 2000, what percentage has Skidmore reduced its annual greenhouse gas emissions by? Yeah, you can just shout it out. 55%. Okay, 55. Any other guesses? 52, okay. We got one more hand in the back. Ooh, okay. Yeah, you can just shout. 51, okay. All right, any more guesses before I give out the prize? Alrighty, it was 52.6. Ooh. Yeah, so if you want to come on up, I've got a tumbler for you and a gift card.
Thank you so much.
All right, yeah, you're
Appreciate
welcome.
it.
There you go. And which one do you want?
Any of them.
All right, take your pick.
Thank you so much.
Awesome, yeah, thank you. All righty. So question number 2, about how many geothermal wells are installed across Skidmore's campus?
405.
You can just shout out an answer.
140.
140?
405.
405? Okay, any other guesses?
I say 500.
500.
The opposite.
550.
All right. So the actual answer is 700.
Wow.
There's a whole lot of wells. All righty, yeah, so I think 550 got it. So come on up.
Thank you
That's
very
for
much.
you. You're welcome. And then, which one would you like?
Oh, I think I'll take Skidmore.
Awesome.
Thank you
All
so
right.
much.
Yeah, you're welcome. Okay, now for number 3, had to do a little bit of mental gymnastics to not give away this number during the presentation, but what temperature is the ground here in Saratoga Springs year-round once you get below 6 feet deep?
58.
Okay, we've got 58 degrees.
50?
50? Okay, yeah, shout it out. 62, okay. 70, all right, all right. Any other guesses? 52, okay. So I will say that so far all of the guesses have been over, so keep them coming.
45 degrees.
45?
40?
40, okay. 42. All right, any more guesses? 37. All right. So the actual number is 49 degrees, which is also the average annual air temperature here. So things just average right out once you get deep enough underground. Okay, so who was our closest there? I think we had a 45 back here. Yeah, come on up. All right, there you are. Oh, I've got a gift card for you. Yeah, do you want the Skidmore or the Amazon? There you go. Okay, question number 4. What year did Skidmore get their first ground source heat pump installed?
2007.
Ooh, 2007, okay.
2001.
All righty, we've got a 2001. 2000. 2004, okay, okay. 2009. All righty, we're all grouped up in the early 2000s, pretty promising. So the actual answer is 2006. It was Northwood Village. Yeah, so come on up, yeah. Woo. Alrighty, so that's for you, and then which one would you like? Perfect. Alrighty, so last trivia question. How many experienced clean heat sites are there? This one's a, what was that?
45.
45, okay.
63.
63.
36.
We've got a 36, nice. Alrighty, last one. If you've got a guess, shout it out. 39, okay. 60. Okay, so the actual answer is 46. So I think 45's got it. All right, so I'll give you that. And then which one would you like?
Thank you.
Perfect, thank you. All righty, and then that is the last of my questions. So now that you've answered my questions, I'm happy to take questions from all of you. Yes?
This may have been mentioned, but I heard a murmur of air like pumps, like the opposite of the ground. What's up with this?
Oh, yeah. So the question is, there was a reference to air source heat pumps, and what is the deal with those? So an air source heat pump is a lot more like a traditional air conditioner, but like the ground source heat pumps, they can run in reverse. So air source heat pumps have come a really long way in the past decade or two. They've been really popular heat sources down south where the weather's mild for years and years, probably since like the 80s or 90s. And now, in the past few decades, the technology has gotten a lot better, especially at extreme cold temperatures. It's gotten to the point where you can actually run an air source heat pump year-round in upstate New York as the only heat source. You do just do a bit better on efficiency with ground source because when you've had weather like the past week where it's 0 degrees outside, if you can go underground and gather heat from where it's 49 degrees, there's just more heat to get. Takes a little bit less energy to do it. Yeah, thank you. Yes?
So given that the ground temperature is only 48 degrees, how does the actual system absorb heat and get hotter than that? Like, I don't understand enough physics to understand how it's possible.
Oh, yeah, so that comes from the refrigerant. So basically the heat pump controls the temperature that the refrigerant boils at. And there's a large energy transfer when the refrigerant goes from a liquid to a gas or back. So if you can get that boiling point down low enough, you can actually gather energy at a low temperature, and then the refrigerant comes back in a steady state, and then you change the pressure, change the boiling point, and release the energy at a higher temperature, let's say 70 degrees inside. Yes?
I have a question about, you mentioned Fort Ticonderoga as a site where there is one of these, and I'm curious about like considerations for installing something like this in a historic structure and like how that process is kind of navigated.
Oh, so that is a great question, but unfortunately it's one that I don't have a lot of information on. I know that being a historic site, they were very careful about not disturbing their site, about not having a lot of visual changes to the historic elements of the building, but unfortunately I don't know a lot of specifics about that. Yeah, maybe you can go check it out and let me know. Yes.
I just have a practical question. We're looking at installing heat pumps in our home, and I have been to the Clean Heat website, and I had one contractor come out. We'd like to do some of the house ducted heat pumps, but most of the contractors I've talked to, I've probably talked to 4 or 5, don't do the ducted, they do the mini splits. I'm wondering if NYSERDA maintains a list of contractors, like in Saratoga County, who will do ducted air source heat pumps and as well as just the mini splits.
Okay, so it sounds like you might have already been here, but the New York State Clean Heat Program maintains a contractor list. So is that the one that you went to?
I did go to that, and it doesn't say, it just has the list. It doesn't say, like, there's no way for me to narrow it down except by calling HVAC contractors. And so I'm willing to do that, but it would just be faster.
Okay.
If I had a list of folks who would do the ducted.
Yeah, so I don't know of anywhere that is split out by ducted and ductless. They do have it divided by air source and ground source, but not by the distribution type. So it, yeah, unfortunately might just be a matter of calling around to contractors.
Okay, thank you.
Yeah, you're welcome. All right, yes?
I may have missed this in the presentation, but so through NYSERDA, are there specific grants or programs for like small businesses to put these systems in their facilities? I guess, is there any support through that?
Oh,
I may have
you know
missed
what?
this, but
no, I actually, I am not sure about that.
okay.
Yeah, is that all right if I read up on that and find some answers? Frankly, I just mostly work on the residential side, so I don't want to misspeak about programs in other building categories.
Are there grants for residential?
Yes, there are. Yeah, so most of those grants come through the utilities. And I think there's a question over here.
I work in the library, and so you may or may not know the answer to this question, but maybe Tara does. Which of the loops or district systems is the library on?
None of it. It's not on the geothermal.
It's not.
No.
How are we going to find it?
Yeah.
Okay, awesome, thank you. Yeah, yes.
So did you have any involvement with Skidmore doing the heat pumps at all, or are you just talking about it?
Nope, I'm just talking about it. So yeah, I'm here on behalf of NYSERDA. I just talk about heat pumps, write about heat pumps.
Okay.
Yeah, not really involved with the installation. Yeah.
Yeah, I have another question. For the geothermal heat pump installers, do you know if they typically all offer the 3 designs that you cover for residential, or?
Generally, the ground source heat pump contractors will specialize in one design.
Okay.
So I would say the vertical wells are the most common, followed by the horizontal, and then only maybe 10% of the market is direct exchange.
Okay, thank you.
Yeah, no problem. All right. Yeah, any more questions for me?
Well, can you speak to any of the economics? And it's fine if not, but right, presumably these systems are higher capital cost, right,
Yep.
than traditional systems, but lower total cost of ownership over time. Are there any sort of fast facts? Obviously, system design would make an impact, but in terms of like where you're kind of reaching your payback, or where then your fuel is free and
Yeah.
good.
Yeah, so that does depend a lot on the system design and the cost of the fuel and electricity. So it's hard to pick a number for a payback period. But yeah, you're exactly right about the general principle that typically ground source heat pumps are more expensive upfront. But then because they are so efficient, the operating costs are lower. So eventually, over a period of years, they end up being cheaper than fossil fuel systems. And eventually, at some point in the lifespan of the equipment, it's basically paid for itself relative to your other project types. All right, any other questions? I am going to stick around afterwards for a little bit. Yeah, we have some heat pump information and stickers over by the snacks. So help yourself to all of the above. And yeah, thank you all very much for coming out tonight.